Welcome, everyone, to today's explainer. Okay, let's just dive right into this because if you are currently preparing for the Cambridge Computer Science 9618 syllabus, you already know it is an absolute beast. It really is. But here's the secret that separates the top tier candidates from the rest of the pack. This exam, it's not a sprint of raw memorization. No way. It is a marathon. It requires pacing, extreme energy management, and a highly strategic approach to problem solving. Today, we're focusing on one of the most notoriously tricky yet absolutely essential topics that appears in virtually every single examination series, and that is using bit manipulation to monitor and control devices. Whether you are transitioning from earlier foundational syllabuses like 0417, 0478, 0983, 0984, or 2210, or you're deeply entrenched in your A-level 9618 prep right now, the strategies we're outlining today will completely shift how you handle complex questions. Think of this session as your ultimate marathon pacing guide. Here's the masterclass journey we are taking today. We'll start with the challenge, move into the strategy reveal, look at the transformation, dive into an interactive workshop, and finally, wrap up with the final system and pitfalls. Let's get moving. Section 1, the challenge, applying theoretical concepts to unfamiliar exam contexts. You see, the high-stakes reality of the 9618 exam is that examiners aren't just going to hand you a simple question like, what is an and mask? Life isn't that easy. Instead, they're going to give you a complex, totally unfamiliar scenario. Imagine a microprocessor controlling the temperature and pressure valves in a massive chemical plant, and they ask you to use bit manipulation to solve a highly specific problem within that plant. So the absolutely crucial question we have to ask is this: why do students find applying bit manipulation concepts to these unfamiliar contexts so incredibly hard? Well, the answer lies in the academic benchmarks of the assessment framework itself. The Cambridge examiners prioritize analytical depth over superficial breadth. They do not just want to see that you've memorized the textbook definitions of bitwise operators like AND, OR, and XOR. They require logical, structured reasoning that integrates seamlessly with other syllabus areas. The whole conceptual framework draws heavily on systematic analysis and evidence-based reasoning. If you just spray facts onto the page without anchoring them to the specific context, you are going to hit a brick wall. Let's look at a real-world past paper scenario to really understand this. Think about a classic 9713 or 9618 question asking how to check if bit 4 of a status register is currently set. We generally see two very distinct student archetypes here. First, we have Alex. Now, Alex is brilliant, but Alex panics under pressure. Alex's approach overloads the answer with raw computer science facts. We're talking defining binary, explaining hexadecimal, listing every single bitwise operator known to man. But Alex demonstrates absolutely zero analytical depth regarding the specific question asked. Because of this, Alex bleeds marks. Then, on the flip side, we have Sam. Sam's approach is basically a chaotic sprint. Sam rushes through, spots the word check, scribbles down use and and mask, and just moves on to the next page. Sam completely misses the command word requirements. When a question says, explain how, that means you need to specify the exact mask, like the hex value 01, and describe the logical bitwise operation, plus the expected result. Sam provides superficial breadth, and consequently leaves incredibly easy marks on the table. Both of these marathon runners burned all their energy in the entirely wrong places. Section 2, the strategy reveal, core principles and the assessment framework. This right here, this is your secret weapon. It's called the method mark strategy. This is a core assessment principle where marks are actually awarded for the systematic process, the logical reasoning, and the clear working rather than just getting the final answer perfectly right. Listen carefully, because this should instantly lower your exam anxiety. When you're tackling a really complex bit manipulation problem, algorithmic thinking requires step-by-step decomposition. If you make a tiny, silly arithmetic error in calculating your hexadecimal mask, but you explicitly showed your clear working, proving that you fully intended to isolate a bit using a logical AND operation, the examiner can still award you method marks for your systematic process. You are being rewarded for the architecture of your thought process, not just being a human calculator. To practically implement that strategy, top-tier students use a structured framework to decode computer science command words. We call this the PEAL framework: point, evidence, explanation, and link. First, you make your technical point. Then, you provide evidence or data directly from the scenario. Next, you explain the logical reasoning or the specific bitwise operation. And finally, you link it directly back to the context of the control device. Using PEAL is exactly what prevents you from becoming an Alex who dumps useless facts or a Sam who writes way too superficially. It paces your answer perfectly. Now, quick pause. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, moving into Section 3, the transformation, procedural framework for bit manipulation. Systematic processing within this syllabus follows a very strict, standardized sequence. Let's walk through these 5 steps. First, identify the key elements. Exactly what bits are we monitoring or changing here? Second, apply the relevant principles. Do we need to set a bit with an OR mask, clear it with an AND mask, or toggle it with an XOR mask? Third, execute the analysis with clear working. Literally write down your binary masks and show the operation happening. Fourth, verify your results. Take a breath and check your logic. And fifth, present your answer in the appropriate format using the correct terminology. This procedural framework develops the exact rigorous programming skills and efficient code implementation that examiners are demanding from you. Let's actually watch this transformation happen live. Consider a typical flawed answer from a student. It might read something like, use a mask to check the bit, and it with the register. Okay, this is a highly generic response. It lacks clear notation, and it absolutely isn't linked to the context. It's an instant red flag for examiners. You're getting basically nothing for that. Now, consider the perfected answer. It says, to monitor the status of the pressure valve at bit 3, apply a bitwise AND mask of 00001000, which is hex 08, to the status register. If the resulting value is greater than 0, the valve is open. Look at that green checkmark-worthy methodical execution. It uses precise definitions, states the exact mask, and links directly back to the scenario of the pressure valve. It is a masterpiece of an answer. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Section 4, the interactive workshop. Deconstruct, solve, evaluate. Okay, I want you to mentally engage with this process right now. Imagine a 60-second timer counting down in your head. When you're sitting in the exam hall and you see a complex data source or a really dense paragraph explaining a hardware control system, your brain needs to instantly snap into this matrix. You first deconstruct. This means you extract the relevant data, like the initial register states, and you select your analytical framework. Then you execute. You use clear notation, making absolutely sure you write out your binary or hex correctly. Finally, you evaluate. You check for reasonableness. Does your resulting bit pattern actually make sense for turning off a physical motor? This 3-step action plan is the core trend for solving complex control device scenarios under intense time pressure. Here is the ultimate blueprint for algorithmic thinking. These 5 problem-solving steps are the deconstruct, solve, evaluate loop, broken down into its absolute finest components. Step 1, identify the given information. Step 2, break the problem into logical steps. Maybe you actually need to shift bits logically before you even apply a mask. Step 3, solve systematically. Step 4, check for reasonability. And Step 5, make justified recommendations based on the output. If you memorize this exact sequence, you will literally never freeze up when faced with a 6-mark application question ever again. Now, what if the command word asks for a comparative analysis? Say the question is comparing the use of a bitwise shift versus a multiplication operation. Here are the strict rules you must follow to get those marks. You must identify similarities and differences. You must use comparative connectives like whereas or conversely. You must support each comparison with direct evidence from the provided scenario, and you must draw conclusions about their relative importance or efficiency. I challenge you right now. Imagine a 30-second timer and try to speed write a perfect Peel paragraph using these criteria in your head. It forces you to be precise, concise, and incredibly sharp. Section 5, the final system and pitfalls. Principal Examiner Insights. Let's start this final section with the biggest, most glaring warning of all. Listen to this direct quote very carefully. Examiner alert. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. So the absolutely crucial takeaway here is that a generic answer is your biggest threat. You could write a perfectly accurate, beautifully worded thesis on the history of bitwise operators, but if the question is about monitoring a greenhouse temperature sensor and you never once mention the greenhouse or the sensor, you will score a 0. The theoretical architecture of your answer must rest on causal relationships that are integrated tightly with the context. Let's rapid fire the top 3 fatal mistakes students make when monitoring or controlling devices. Mistake number 1, forgetting to check overflow and edge cases in bit manipulation. Think about it. When you shift bits left or right, what happens to the bits that fall off the end? Did you account for it in your logic? Mistake number 2, forgetting to check boundary conditions. If a sensor value crosses a specific threshold, does your algorithm handle that exact boundary value correctly, or does it fail? And mistake number 3, as we literally just discussed, providing answers that are not specific to the context given. These are easy, painful marks lost purely to poor exam technique. To help you lock this theoretical architecture into your brain for exam day, I'm going to give you a powerful memory hack. Use a visual story method. Encode using bit manipulation to monitor and control devices concepts by visualizing real physical objects. Imagine an actual physical mask with holes punched in it. An AND mask only lets light through where there is a hole, representing a 1, so it isolates exactly what you want to monitor. An OR mask, on the other hand, acts like a heavy rubber stamp, forcing a 1 onto the surface to set a device to on. By visualizing these operations as physical actions in a story, you completely eliminate the abstract confusion and ensure your algorithmic thinking remains grounded and precise, even under extreme exam pressure. If you can master this system, command word decoding, the PL framework, and the deconstruct solve evaluate loop, the results are going to be staggering. Students who implement these computer science strategies see an average improvement of 2 full grade boundaries, but that's only if they practice consistently with our weekly explainers. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to at Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. I'm going to leave you with this provocative thought to carry into your next study session. Will your next bit manipulation answer be a generic sprint that runs out of steam and loses all the easy marks? Or will it be a carefully paced, context-driven marathon that secures every single method mark available? The choice is entirely yours. Drop a comment below right now with your target grade for computer science and the absolutely biggest challenge you're currently facing. Our team responds to every single comment. Like and share this explainer with a study partner who needs to hear this. Ace the Exams, your Cambridge success starts here. Thank you for joining this explainer. Stay focused, keep applying that context, and I will see you next time.